use it and be able to answer the question. For those of you just joining us, the warm-up was give yourself 2 minutes, ready, set, go. Solve each of those without a calculator, without your notes, without a phone, and without a friend. And what did you guys just respond? How did the last 2 minutes go?
Not good.
There was complaining. There was, well, she's going to do it and then I'll get it. There was, I hate trigonometry. There was all sorts of stuff. Unit circle. I can picture a circle. Okay, that's good. Glad I can picture a circle. Coming back. How many of you were not able to answer confidently any of those questions? Okay, hands down. We have been working on this, section 4.2, 4.3, and 4.4.
And then all of last year.
And all of last year. Not all. Part of last year.
Like the in-person.
So pause. The point of the cheater chart, the point of the geometry, the point of the unit circle was to say there are different ways for your brain to be able to do this. But right now, we all just admitted we can't do this, despite the homework, despite the notes, despite the practice. So what do I need you to do over break?
Practice.
Figure out how to do this. But what is today right now for? To remind you of the 3 different ways of tackling these types of ideas. How many questions do we have? 3. How many ways did I just refer to we have to do this? 3. There's a 4.2 way. I'm going to do that in number 1. So I'm going to do number 1, the 4.2 way, which has to do with a circle with ordered pairs. I'm going to do this one, the 4.3 way, which had to do with geometry. And I'm going to do this one, the section 4.4 way, which landed us at something that I called the cheater chart. Now, do you need to know all 3 ways? In some ways, yes, to be able to do things like SOHCAHTOA. In some ways, yes, to be able to do things like coterminal angles. In some ways, yes. Okay, in some ways, yes. But for answering these big idea questions, no, you just have to pick one and then get really good at it. Question, what would happen if right now I was to go to Google? Oh, this is a horrible teacher thing to do. I should never do this, but I'm doing it because I'm so confident. And I was to type in unit circle, whoops, practice. Oh my goodness, 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 oh my goodness. Is this a thing? Yes. For like all of American math. Yes. For Algebra 2, pre-calculus, calculus, and beyond. The unit circle is a thing. So what if I was to search this and be like, man, I need to practice my unit circle. Look, there's even like a quiz that pops up for you just to start if you want. Or there's a game. Or there's more quizzes. Or you guys like, oh wait, where is it? Here. You guys like quizzes. Look, oh my goodness, there's so many quizzes. Look at them. Look, there's so many. There's tons. And they have games. Okay. Is there a place to practice?
Yes.
Guys, unit circle for the beyond is kind of like factoring for the now. Was factoring a thing that you needed to get better at? Is factoring still a thing that a lot of you still need to get better at? But did you start seeing it in Algebra 1 and just now in pre-cal some of you are realizing, oh, I should probably learn that? Our unit circle started last year and it's like factoring as in such a fundamental skill to build. So anyway, all that to say, hey, look, what is the easiest way to learn the unit circle? Are there YouTube videos? Oh my goodness. Okay, pause, focus, or else my voice is not going to last today. Shh. Thank you. I'm going to do the 4.2 way, 4.3 way, 4.4 way, and then I'm going to ask you to vote for which way you right now like better, and then you're going to take break to try to get better at whichever one you choose, and you might change your mind in the midst of the work. The goal is to be able to answer 3 random ones given to you from SOHCAHTOA, HPC. Those are 6 different trig functions, sine, cosine, tangent, cosecant, secant, cotangent, of any angle in the unit circle, and pop off with it. Within, well, I let you guys, let's see. Let's just say like a minute each, even though hopefully it'll get even faster than that. But to be able to pop off, maybe from your brain or maybe after a little bit of work. Ready? Section 4.2. Some of you, Joey, it was you, wasn't it, that said, I can think or I can visualize a circle. I'm not sure I got you the answers, but you can visualize a circle.
The unit circle is
For section 4.2, we started with a circle with little ordered pairs, and I did not really compare it or tie it together with geometry. That happened later. So if I was just thinking about a circle, question, what quadrant would I be in for 4 pi over 3? Third. Why? Because it's 3 over 3. Remember how I did that? It's 3 over 3. It's a calzone. Oh, bonus. It'll pop up in Google Classroom by the end of today to get a calzone over break. To remind yourself that pi is a calzone, is half a circle. It's 3 over 3. Cut it into thirds and be like, look, it's pi over 3. It's 2 pi over 3. I'm going to eat 3 pi over 3. Well, it depends on who you're with. Okay, so 3 over 3. Where's 4 pi over 3? 1 more. Right? 1 more would put me right there. Right here, in the unit circle, I have ordered pairs, and those ordered pairs, as long as they're from the unit circle, we saw ordered pairs in a later section that are not in the unit circle, they're too big, but as long as they're in the unit circle, which I'm coming from, are going to give me negative smaller, negative bigger. In this section, I told you that there were 5 key values for sines and cosines, 0, 1/2, root 2 over 2, root 3 over 2, and 1. Later, we saw in geometry where those came from. But I'm negative smaller, negative bigger, at a pi over 3, which is a reference angle of 60, all things we learned later. Sine is the, well, is sine the opposite one? Or is sine the adjacent one? So, katoa, opposite. Is opposite the x or the y? So therefore, this final answer was negative root 3 over 2. Any questions about how to answer one of these the unit circle way? Ryan, go.
Wait, so when you solved for the points, did you do that?
Oh, I didn't solve for the points. I just reminded you guys that there are 5 key numbers. And if you know the 5 key numbers, this is the smaller of the 5, which is 1/2. This is the bigger of the 5, which is root 3 over 2 because it's longer. And they're both negative because it's the third quadrant. So I haven't done any solving for the numbers. This is, I have the 5 numbers memorized. That's this one.
You have to memorize the whole unit circle.
Do you? I think I only have to memorize this order pair, this order pair, this order pair, and then be able to go negatively. The symmetry is there because this is the exact same order pair as this triangle in the first quadrant, which also had 1/2 and root 3 over 2. I just went a negative way and a negative way. I stole this triangle to make that triangle.
So you only need 4 and then you can use the
I stole this triangle.
Just made it negative.
So I made the x negative and I made the y negative because I knew how to move.
Because in the second quadrant, if you're moving it, you're just making the x negative because the x is negative and the y is positive. And then in the quadrant 4, you would make the x positive and the y negative.
All you need to really memorize is the first quadrant. If you know how to move it around your unit circle. You see it? Yeah, exactly. Exactly.
Okay.
We're gonna add that to the list.
Okay, section. I just started that today. You have to wait till I do it some more. If I do it some more. Okay, section 4.2. There was a circle, and the circle had x's and y's. Wait, what if you needed tangent? That's not an x, that's not a y. Oh, there was a table of formulas, and tangent was y over x. Do you remember 4.2?
C.
The x and the y could be used for everybody, but you got to know how. Section 4.3 says there's a thing called geometry. And it somehow ties together with stuff like this. In things like geometry, we would still need to think about where 11 pi over 6 is. What quadrant is 11 pi over 6? I have 6 pi over 6, so I'm way past that one, but I'm not quite to 12 pi over 6. That's if I have 2 calzones. I'm 1 slice shy. I'm 1/6 shy of 12 pi over 6. I'm 1 slice shy. Now if it's 11 pi over 6, wait a minute, hold on. 11 pi over 6, isn't that 1/6 the reference angle? Here's geometry, the reference angle. Technically it's kind of 4.4 as well. The reference angle is the little baby one. Guys, what's the smallest special angle in geometry? 30. Oh, this is a 30, 60, 90 triangle, but if I was to use geometry, it's way bigger than the unit circle, but whatever, that's okay, because the ratios are the same. There's this whole property about similar shapes, proportional sides. So I can go outside the unit circle and say, it's a 30, which I could think of as a 1, and as a 2, and as a root 3, except I told you, watch out for signs, because we're thinking about the actual positioning, so I need to make the 1 a negative, because it's down. I'm going to make the 1 a negative, because I'm going down. I have a positive root 3, a negative 1, and my hypotenuse is always positive a 2. If you have a right triangle, can you get trig out of it? Booyah! So which one do you want? Which one do you want? You just have to read it. Cos. Who is cos?
Opposite.
Oh, the x. Oh, the x is in this way. We're looking at a triangle.
Adjacent over hypotenuse.
Okay, good. Can you first just tell me the name? Who is this guy? Cosine. Can everybody say it? So we know what this is. COS is what again?
Cosine.
Okay, just making sure. Because you didn't answer a second ago. We're finding cosine. And then Noah, why did you say adjacent over hypotenuse? So ka. So I'm looking for ka. Do I have a triangle? Yes. Can I answer from the triangle? Yes. What is the adjacent to the reference angle? Root 3. What is the hypotenuse to this reference angle? Dun 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 dun. Guess what? That's also the x in that spot on your circle. Johnny.
So if I wanted to solve one of these problems, I could just draw the unit circle every time.
Yes. And in some ways, like at the beginning of a test, or in some ways at the beginning of a quiz, or in some ways at the beginning of a final, that time would be well spent to draw the entire circle. But more typically, as far as future application, it's best and fastest to be able to draw one quadrant and use symmetry to get there. So my advice, if you like the unit circle, is try to get good at one quadrant and being able to get to whatever quadrant you need. Does that make sense?
Yeah.
Okay. But yes. Section 4.4 was another way, and I called it the cheater chart way. But Ryan, or anybody else, any questions on the geometry way first? You need to know your special triangles, and you need to be able to figure out what reference angle. Is it a 30, is it a 45, or is it a 60, and how do I do that? If you're on an axis, sadly, I would, for all the axes ones, I would probably just stick to the circle in the sense of, hey, cosine's 1, sine is 0. Hey, cosine is 0, sine is 1. Hey, why? Because you can't really draw a triangle if it doesn't go up anywhere. Or you can't really draw a triangle if it doesn't go out anywhere. Now, I could bring in calculus and the idea of limits, and we could kind of still do it, but that's not something for today. Ryan, go.
How do you know that the side length would be -1?
Oh, well, I know geometry, and across from the 30 degree, I know is a 1a and a root 3a and a 2a, so I'm just using the most basic 1, 2, root 3. But I'm going down, so the same way I have to think about movement, because it's not just geometry with length anymore, it's actual direction, like directed segments. I need to realize in the fourth quadrant, all students take calculus. That's one way, the cosine is positive, or the other way is to make your triangle with the signs, which is safest, smartest. Because when you're in the midst of Sokotoa Tosha cow, to have that negative where it needs to be is probably best. Does that make sense? Right.
So, let me just, off the top of my head, I know pi over 6 is 30 degrees because half of it needs to be 90. So 3 pi over 6 needs to be 90, so
1/3 of that and 1/3 of 90 is, yeah. Or you could think of 1/6 of 180 because pi is 180. But either way,
Yeah, and then, so 11 over pi over 6 would be
a 30. In the,
And then,
throw in a 30, 60, 90 ratio.
you draw the line to the line nearest of it.
Oh, to the x. Always to the x. Good.
And then cosine, do we do it the opposite?
No, so ka. So adjacent. Which is why I had to choose the adjacent side and the hypotenuse side. So would have been opposite of hypotenuse.
So what is that, like x or y?
But we're not doing it this way because we're not in the unit circle. We're doing it a triangle way because I'm showing you or reminding you geometry is a method.
So you're doing like you're counting the units.
I'm using the special ratios of a special triangle from geometry, 1, 2, root 3,
How'd you know that again?
from geometry. So it's in our notes, a 45, 45 has special
It's
ratios,
30
and a 30, 60, 90 has special ratios.
Then you just solve. Okay.
For whatever you need. Opposites, adjacents, hypotenuses, do SOHCAHTOA, CHOSHA-COW,
How
however
did
you
you
need.
know we're not in a unit circle for this?
Oh, remember, I'm showing you different methods. So if you were to turn to your circle right now, and if you were to go into 11 pi over 6, it would have this x value of root 3 over 2. You could have found it that way as well, but that would have been a unit circle way. I'm showing you an alternative method to getting the exact same answer. This would have been in a circle, and if you knew the circle, you could have gotten that.
But cosine is x, right?
In the circle. But I'm outside the circle because I'm way bigger. I'm not a radius of 1, I'm a radius of, okay, I made it a little extreme, but I made a radius of 2 for my geometry special triangle. But I could have gotten it from the circle. I was just showing you the other way of looking at it. Does that make sense, kind of?
Yeah. In tan in the circle, what is it?
Oh, in a circle, you'd have to go back to 4.2, and there's like a table of formulas where cosine was x. Actually, I think they started with sine. Sine was y, cosine was x, tangent was y over x. Yeah. But if you had the triangle, it could just be opposite over adjacent, which might be a little easier in the numbers. But I've actually saved tangent for the bottom one. I've actually saved tangent for the bottom one. Because, for whatever reason, my brain, after having done unit circle and taught unit circle for a long, long time now, has now, like currently, in my current state, I always think of tangent in the cheater chart. Doesn't mean you have to. Ryan was just saying, like, how would you get tangent the unit circle way? You have to divide the y over the x, like the formulas tell you in the x's and y's table of formulas in 4.2. How would you get tangent the triangle way? Well, you would do SOHCAHTOA, opposite over adjacent, if you've drawn the triangle. That's how you get tangent. How do you get tangent the cheater chart way? You sing your song. 1, 2, that's not it. 1, 2, 3. That's sine. 3, 2, 1. That's cosine. All over 2's and square roots. We're now to the tangent row. Square root of 3 over 3, but that's a 30 degree. 1, that's a 45. Square root of 3. That's a 60, but this is a 45, so therefore I know it's a 1. I just sing square root of 3 over 3, 1. Oh, it's a 1. Wait, but it's in the second quadrant. Oh yeah, because I have 4 over 4. And I'm 1/4 shy. All students. S is positive, not tangent. Dun, 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 boop, boop.
Oh.
But how'd I do it?
Wait, how do you know it's not?
I sung my song and I knew where I was.
So we sing the song and we know?
Well, I know this cheater chart real good. If you sing the song, you could be having no clue what's going on. But if you know the chart goes like shh. If you know the cheater chart is SOHCAHTOA, S then C then tangent, sine then cosine then tangent. If you know that the song goes 1, 2, 3, those are telling me the signs, a quick way to remember the order of those special 5 numbers. Cosine, 3, 2, 1, those are the cosines. Wait, what are they for? Oh, the 30s and the 45s and the 60s, which I know the 6s are 30s and the 4ths are 45s and the 3rds are 60s. So I looked and I saw, oh, hey, no big deal, it's a 45.
Oh,
So then I just sung my song and said, I wasn't in the 1, 2, 3, I wasn't in the 3, 2, 1, I was in the square root of 3 over 3, 1, ha-ha, 45 is 1. But I needed to check my sign, and so to check my sign, I had to think about, where is it? It's here somewhere. I know it is. There it is. I was in the second quadrant. I knew tangent had to be negative because it's not S, it's T.
Makes sense.
So I got the 1, I put the negative, and I said, I'm done. Now, go ahead.
So, by looking at the denominator, that's how you get the degree. It's like 6 is always
And 1/6, a lot of people think the 1/6 is bigger than the 1/3, but it's like, no, it's not. 1/6 is smaller. So as long as you know it's the 6 and then the 4 and then the 3. You can technically even know like your axes, but once again, I don't know, my brain just likes using the ordered pair for the axes. I think it's easiest, but
Yeah.
I literally just went to the row of square root of 3 over 3, 1 square root of 3. I knew that was tangents, and I knew that my pi over 4 lines up, so I knew it was a 1, but I had to think about the second quadrant. A t is not an s, so it's a negative, and I was done. But my unit circle people, if you had gone to 3 pi over 4, you would have had negative root 2 over 2 and root 2 over 2. When you divide y over x, they're the exact same thing, and reduce it, you get a negative 1. My geometry people, you could have drawn a triangle that had a 45-degree reference angle, and you would have had a 1 and a 1 and a root 2. Ryan, do you see it? But it would have been a negative, because I'm going left. Opposite over adjacent would have been negative 1. All of them lead you to the same place, but you have to know how to use them. Andy?
So, when you use the cheater chart thing,
Yes.
how'd you figure out that you were using 1 if it's 3 pi?
I didn't look at the how many slices. I looked at the what is it cut
So the
into.
pi over 4.
It's cut into 45.
So it's a 45 degree.
So it's at the pi over 4 one, which is the middle of my table.
Wait, so then how? Oh,
Because 1/4, right? 1/4 is there. 1/2 is somewhere else. 3/4 is there. 4/4 is there. 5/4 is there. 6/4 and whatever. So I know that anytime I'm left with a 4 that can't be reduced, I'm always going to be at 45s.
So like if it was like tangent 6 pi over 3 it would just be.
Well, 6 pi over 3 can be reduced. So
Yeah.
reduce it first. That'd be a 2 pi. You'd be at the axis. So that would be one of like the awkward
okay,
zeros.
like 8 pi over 3. So it's just
Yeah,
square
8
root
pi
of
over
3.
3. I know it's going to be square root of 3. I just have to figure out, like, count my thirds. There'd be 6 pi over 3, another third, another third. Oh, all students, tangent is negative. Sweet, put a negative.
Okay.
So anything that is a third after reducing, a fourth after reducing, a sixth after reducing is going to have the same reference angles as what you see here, just in different quadrants. And if you guys can figure out what quadrant, you can assign what sign. Yeah, Ryan.
If you were, or like,
Can we go back to the...
yeah, for those, if the number, or like if you were given like a bigger number or something that had kind of like more like revolutions around, like.
Natalie just gave us one. She gave us 8 pi over 3, which is beyond 6 pi over 3. But still, 8 over 3 is reduced. It's going to hit at one of those 60 degrees.
So you can still use the.
I can still use the number. Well, I can still use the unit circle too, but no matter what, I have to figure out what quadrant to land it on to match it up with the unit circle.
Yeah.
I just won't be able to go straight to the unit circle. Does that make sense? But I would have to figure out the quadrant for any of the other ones either.
Makes sense.
Oh, you guys kill me. We still have 60 seconds. Okay, hold on, pause.
60 seconds.
We have a homework due when we get back. You guys have a day when you get back, a full class period. I think I made the homework due 11:59. Someone double check that for me.
Yeah, today. Yes.
Oh, today. How many of you guys would like longer than today for 4.4? I'll just make it after.
4.3 and 4.4.
Yeah,
I think it's a blended.
Oh,
Okay. So what I'm going to do is I'm going to add on a couple things to Google Classroom. Number one, I'm going to extend that homework just until the Monday we get back, 3:30. I'm going to make it 3:30, not 11:59, 3:30. We can do a little bit of troubleshooting because we didn't do anything today. I'm going to add in an assignment for you guys to do unit circle practice. However, whatever I post, there are a million different ways, or more probably in your Google search, for how to practice the unit circle. What you want to be able to do when you get back, are you hearing me? Who knows what's going to happen, is to be able to answer 3 random questions from the unit circle.
Pop quiz.
But, bonus over break, go eat a calzone. Bye, cool kids, I'll see you later.
Calzone.
Things will be posted, things will be posted, things will be posted.